Welcome back. So in previous video, we set up the communication between the S7 1200 controller and DL-PN1 Profinet device. So that means currently the hardware communication we already set up. So next things we need to identify what the signals within this each slot and what the tag, for example, trigger, busy feedback, or program change, those bit or those tags, where are they? So that means we need to go to the Profinet addressing list. In this menu, it's called a different slot. We need to identify which slot or which bit we need to use. The key information we can get, so we need to look at the detail of this menu, Profinet Communication Module DL-PN1 Users Menu. And we go to the Date I/O Communication. And we scroll down. So this portion, precaution when using TI portal made by Siemens, that is a hardware communication portion. We already done here. So next things, we need to scroll down, go to the device map. So that talk about the communication between the PLC or controller to this device. So the input list here, that means the data flow from the device to controller. That means from controller view, those signals come back from the IX sensor. Or another way, we call that the input of the controller, input of the PLC. So let's go one by one. So the first slot, that is slot 0, that is this line. Totally, it takes 16 bytes here. That is from 630 to 645, 16 bytes. So that means the first byte, it is this, that is 630. And this, that is reserved by the system. So we can use this error status, that is just one bit, to identify if this device or the system has an error. So this bit 630.7. So in the PLC wise, so this byte that is a 630. So this bit that is a 630.7. That's the error status. So I name it input error global here. And let's look at the second slot. Slot number 1, that is this line, x_1, this line. So we start from the 646, that takes 7 bytes here. So we can see this is from 16 to 22. So the address follow like this way. So in this list from So maybe assign the window like this way will be better. So we can clearly see this. Each slot, it can be separated into 2 areas. We can use this line, seeing this as a dash line. So the first byte in each slot, that talks about some system function. For example, for the slot 1, this portion, that is for program change response feedback, trigger timing response something. This is a system wheel. And after this line, we can see from here to here, let's talk about the measurement value 1. I will explain what does mean for the measure value 1. All this portion talk about the measurement value, and this area, that is the system wheel. That is the x_1 here. So if we go to the next, that is slot 2, that is our x_2. Still 6 bytes. So still there's a 1 dash line we can draw by ourselves. So this portion, that is the external output. And especially this is just for main unit. I will explain what does mean for external output. And after this line, that talk about measurement value 2. Value 2 evaluate under over the range and the actual measurement value. if we go to the slot 3, it's the same. So the dash line is here. This 30, this byte talk about the external value from 6 to 10. Still talk about the main unit. And after this line, that is the measurement value 3. This slot 3, that is the x underscore 3. So if we go to the slot 4, the dash line here. So here it shows a little bit different. Look at this. So this is that 1 byte. This is the program change response expansion unit. Take care about this. This is still a system function. From the slot 4, this byte, the response coming from the response represent the expansion unit. If we quickly go to the slot 1, this is slot 1. See this? Programming change response. That is for main unit. For the slot 4, that is for expansion unit. And still, after this dash line, that will be the measurement value 4. If we shift to slot 5, so slot 5 corresponding with x underscore 5 here. So the first byte, that is a system value, that is an external output 1, but this time it represents the expansion unit. And after this dash line, this whole area talk about the measurement 5. And let's go to the slot 6. The slot 6, that corresponding with this x underscore 6. And dash line is here. So this area talk about the external output 6. This represents expansion unit. After this dash line, this area, that is the measurement value 6. For my personal view, at the beginning, I really confused with this address. That means for each slot, actually, they have 2 areas. One area, the first byte of each slot, that talk about the system function. And the next couple bytes, the next 6 bytes, that talk about the measurement value. Take care about this. And from slot 1 to 3, and from slot 1 to number 3, that this first byte all talk about the main unit. Slot 2, main unit. Slot 3, main unit. And from slot 4, 5, 6, that all talk about the expansion unit. For example, programming change response, timing response, measurement value results, update complete response, and external output. So this is a mapping between this internal Profinet tag to the PLC tag address. Till here, maybe someone will ask me, so what does mean for this external output and measurement value? To explain this, we need to go back to X Navigator. I will show in the X Navigator settings. So if we go back to X Navigator, I will use this offline simulation, open one archived project, and I will explain what the relationship between the external output and the measurement value. This is that project. In this laser sensor, we will set up the different tool, for example, the step or the actual measurement. Each tool will give you one result. You can sort each of the tool result to this output. From this output, by default, it has a 10 area here. And by default, the first one, usually we will take the total status. That means one of the tools reject, the total status will become bad. This bit will go off. 1 means good. If you want to toggle this result, for example, good means 0, you can toggle this result. If you shift to programming mode, you can assign this. Currently, I'm just opening simulation status. So from here, that named output assignment. This output assignment related the mapping address is this area named external output. So if those results come from the master unit, so those results according to the slot 2, external output 1 to 5, go to the next slot from 6 to 10. This is the 10. This is the external 10 results. This is the main unit. If those result comes from the expansion unit, so those results we need to go to slot 5, expansion output 1 to 5. 5 is here. Slot 6, that is from 6 to 10, that is a 6 to 10 in this list. So personally, I highly recommend Keyence can rename this. That makes your understanding easy. So it named output assignment, so it's not match. So this name doesn't match with here. It will be a little bit of misunderstanding. So next thing, what does mean for this measurement value? If we shift back to this X Navigator, so when we set up the sensor, there is one important step. We go to advanced sensor setting. We go to advanced sensor setting and we shift to main with expansion unit operations. Or we go to the device. Here's one setting, communication unit DL setting. We go to setting. Because I'm using the simulation mode, so it doesn't allow me to change for that. But you can imagine, so in your case, if you shift to the laser sensor to programming mode, so it allows you to change this setting. So the measurement value is talking about this area. This is the measurement 1, 2, 3, 4, 5, 6. So if we review this manual, so the slot 1 under this dash line, we talk about this dash line here. So the measurement value 1 is this position 1. But this measurement value, if it's come from the main or expansion value, that depends on what the value you set here. So in my case, I set the main unit tool number 1 value assigned to this slot. And the second slot, I assigned the number 2 tool come from the main unit. So this number 2 slot, that relates to this here, the slot 2 measurement value 2. That is this position's value. And number 3, slot 3, that is a measurement value 3, that is this position's value. Slot 4, the number 4 slot's value. What kind of value? That totally depends on what you set here. So in my case, I assigned main unit tool number 1, 2, 3 to this top 3. And from the 4, 5, 6, I assigned the expansion value. Actually, in my case, I'm not using this actual value, but I just leave them as a spare. So slot 5, the measurement value 5 is this position's value. Slot 6, that is this position value. So we can see this name still called output assignment. If we review the external output in this software, it also called output assignment. I highly recommend this name could be a change, at least match this name. So we can call this area, call this measurement value assignment, and call the output there called external output. So that can make the software and this communication match. But maybe because this manual is talking about this DL-PN1 device. Maybe this module will serve for different series product, so they may call a different name. So we really need to take care about this. This name and this table for the new starter really a little bit confused. Here we do a quickly summary. So in each slot, it has a tool separation area. The top 1 byte is talk about the tool output. So the under this area, that's the measurement value, that comes from the advanced sensor setting. And that is the communication unit DL setting here. And after we clarified what does mean for each bit, or what does mean for this value, we will set up the tag name in our project. I'm trying to organize my screen to make them match together. So let's quickly review. For the slot 1, that is x_1, the first bit, that is a programming change response. So in our case, that is this bit. So this main unit programming change response, that is a 646.0. So in our case, that is here. The input 646.0, that is a job change response from main unit. So the second, that is the timing response, still the first byte, so that is a 646.1, that is a trigger response from the main unit. And for example, the bit 3, that is the measurement value result update complete. So in our case, that is 646.3, that is a value result update complete. So we follow this list, assigned each input address for that. So if we go to slot 4, that talk about the expansion unit. So expansion unit, that is a slot 4. So according to this line, x_4, the first byte, that is a 667. So the first bit programming change response from expansion unit, that is 67.0. That is a job change response from expansion unit. This. So the result update complete from this 0.3 bit, that is this line. From the input 667, the first input byte, and the third bit, that is 0.3, update complete from expansion unit. To pick the results, we talk about this external output number 1 from main unit. Because this is a slot 2, the first byte 653, slot 2, so the results from the tool 1, 2, 3, 4, so that the first tool result, that is 653.0. That is from extension output 1 from main unit. Next tool result, that is 0.1, 0.2, 0.3. So these results match the output from the sensor. So those output match the sensor output. For example, output 1, that is total status, that is this. Second one, that is busy, that is the second line. If we assign the 3, 4, 5, so that is followed this way, 3, 4, 5. That come from, so that come from this list. Number one, follow this byte, slot 2. So we go to this number 1 here. And result number 2 busy, we go to this. So this is the relationship between this Profinet map and the software X Navigator result and the PLC input address. So talk about this output. So if we go to the list from this document, Profinet I/O controller go to this device. That is the PLC output. Give a command to this device. So we can see the first byte that is reserved for the system. So in our case, the first byte, and from next slot, the slot 1, that is x_1. In our case, that is 631. So that means the first bit, that is the trigger signal. It's very important to trigger the laser sensor so that we got a picture, got the result. That is a trigger control signal for the main unit. So for this output, that is the output 631.0. That is for main unit. So if we go to this tag list, so 631.0, that is the main unit trigger signal. In Siemens logic, the output named Q. That means output. And second one, if we want to use the reset request to reset the main unit, that is a 0.2. That is a 0.2 bit. So in this case, that because that's slot 1, so this 0.2, that means 631.2. So if we go back here, that the reset signal to the main unit, that is a Q 631.2. And if we need a program change request, that shift to slot 2. Slot 2 is here. So that means if we want to send a command to request a programming change in the main unit, so this address will be 632.0. So in our tag list, that is 632.0. That's the job change request to main unit. For the expansion unit, same idea. We need to shift to slot 4. So in the slot 4, this byte, so the first one 0, that is a trigger request to the expansion unit. So in our case, that is a x_4 slot. So this bit, that will be the 634.0. That is the trigger command to the expansion unit. So in our PLC tag list, that is the Q 634.0. That is the trigger signal for expansion unit. The same way, to change the program on expansion unit, we need to turn to the slot 5. The slot 5 B0, that is the programming change to the expansion unit. That is the slot 5. So this address will be 635.0. So if we go to the PLC tag list, that is a Q 635.0 job change request. So from this video, we basically clarify what does mean on this mapping list, or what the relationship with the PLC address, PLC tag list, and what the basic function for the X laser sensor, because each bit has an internal function according to this X laser sensor. This manual is very important. So we need to read the detail of this manual. And I highly recommend if you go to one site, you better print a paper version of this couple pages, because you can imagine there are a bunch of signals you need to trigger or read. So when you're doing something on site, you need to open this address, open this menu, and open this tag list. It's really complicated. So you better print it out. So this is this video. In next video, we will show how to program a trigger logic, how to read the results from this X laser sensor. We will base on those tag address to do the trigger test. Thanks for watching.
Thank you for watching. If you like this video, please give me a thumb up.
If you like to watch more videos in my channel, please subscribe. See you in next video.